Okay, hello everyone, and welcome to this third webinar session about generative design. Today speaking is myself, Jacques Dutilleux. So I'm still technically in an engineering school, IPSA, in Paris, but I'm currently an intern as an industry solution technical at 3DEXPERIENCE Edu Hub, and I've been there for 2 months, and I'll be staying there for another 4 months after that. Last year, I was also at Dassault Systèmes at CCNT industry, and I was there for 4 months. And today I'm happy to demonstrate 3D generative design. So what is this generative design application? It's a new application, and it's an application that you can access with 3D Generative Innovator Pro. It's a browser-based app, and so you can only use it on the cloud. So in some terms, it allows you to use generative modeling, and it uniquely combines graphical visual scripting and interactive 3D modeling with the ability to use one or the other interchangeably at any time. In other words, it allows you to make graphical scripting, as you can see on the right-hand side of the screen, and at the very same time, see the interactive 3D modeling on the left-hand side of the screen. But I will demonstrate it furthermore later in this presentation. I'd like also to add that it's a really intuitive and it has a really smart approach application. I mean, I've been at the beginning, I've been using it for 2 or 3 days, and I already felt comfortable using this application. And I got really quickly what was the good side and the bad side of this application. Okay, so I would like also to show you a little bit of my current project that is using generative design. My current project is to develop and make a stackable bridge. So it's the thing that you can see on the right-hand side of the screen in this application called xGenerative design. So as you can see, my first draft on the middle of the screen, it's only the geometric part. And at the end, we are hoping that it will be adaptable to any surface, start or endpoints, and along any alignments. So we will make it a template out of 4 inputs. And it will be configurable with any type of bridge, any type of pillar, or stackable. And here we have a second version of my stackable bridge. It's only the skeleton of the stackable bridge, but you can see on the left-hand side of the screen some controllers. And in fact, it's one of the main aspects and the objective of this application, that you can change really easily some parameters in your model, and it will change the geometry really easily and really quickly. So you will be able to make a lot of different shape and patterns really easily. Also, I'd like to add that it's some academic content, and we are not experts. But feel free to ask any question during the presentation, and we will be able to answer them at the end for a little 15 minutes Q&A session. And after that, you will be sending a survey for you to answer, and it will really help us to improve our presentation. So in this presentation, we will see some aspects of generative design. Unfortunately, we can't show you everything because it's only a 40 minutes presentation, and it has a really easy geometry using. So we'll see some basic usage, the input, output, and the function using. We'll also see the geometry making, like point, surface, and volume. And one of the main applications is the list. So we'll see the access of the list, the structure making, the building of this list, and the modifying of this list. Also, at the end, will be available for the little Q&A, and there is a replay available with links shown on our swim page and on our academy.3ds.com website. So now I will start the pre-recorded presentation, and it will stay for 40 minutes, and after that I'll be available to answer the question.
Hello everyone, and welcome back to this presentation about xGenerative design. So today we're gonna produce a piece of Lego with this dimension that you can see on my tab called Webinar in my dashboard. So we'll try to follow up this dimension as well as we can. So we first have to check the application in the West Quadrant. So in my role, let's go to 3D Innovator for Academia, and then you have the xGenerative design application. So you drag and drop it on any dashboard in any tab, and you maximize it. You can drag and drop any models that you want, any 3D XML model directly in xGenerative design, or you can just create a new one by clicking on Create Model. We're gonna call this one Webinar Model, obviously, and it will be saved in my dashboard called GTake3-Perso. So now it's generating a new model in this previous collapse space that I was speaking about earlier, and we arrive on this interface of the application. So you can see the tree that you are familiar with if you use Katia. You can hide and see anything on this tree that you want by just clicking on it on this side of the tree. And you have also the tab called Experiment and Monitor that we will talk about a little bit more later. Then on the first option that you have, in the Fixed Area tab, you have Home button, Save, Return, Go Back, Publish, and Display Graph. The other tab are about generating any geometry that you like. So it's the basic commands that you will find back in the display graph and more other options. But you can use it. It's basically points, rectangles, circle, extrusion, fill, etc. The last tab is View, about how do you want to view your model with parallel perspective and all. You have the shadow, you have mirror. You can use it as you want. Okay, so let's go back in display graph, because this is the thing that we will mainly use today. So this generates another interface where you will be able to script with the command that we will speak about later. And this is what I really like about this application, is that you can have the 3D visual modeling on one side, and the 3D scripting on the other side. So you can see at the same time what you script and what is the visual model of it at the same time, but you will see more later. So let's get to work. In the display graph, you have a lot of different tabs with a lot of different applications, a lot of different command box that you will be able to use in order to do your project. Let me just crop this a little bit better so you can all see. Okay, so for the parameters, there is a lot of different applications that we won't use today, but we will maybe speak more in another video. Tools is the same thing. List is a really useful tab. You have a lot of different applications for this. And geometry, it's the same. Math, we won't use it today, but it's really useful if you want to do some shapes with mathematical function. Image and color, we will maybe see it later. So to begin the basic usage of this application, you can first drag and drop it from tab to the display graph, or you can just click on it. To see the information, you can just hover it with your mouse on the command box, and it will display the more detailed information, what are the inputs needed and what is the output of this command. Okay, so we will take this first command box point on plane to start. On this command box, you can either hide it or see it with this command, activate or deactivate the command box, group it to create a group, it's easier to use after that, duplicate it with or without data flows, and simply delete it. So let's take our first command box called point on plane. So as you can see, as you can guess in the title, we need a plane to extract a point out of it. To link two command boxes, you have to connect the output of ones to the input of the others. To do so, you can drag and drop from one to the other. To erase a link, you just have to drag and drop it back. You can double click on one output and double click on the other input, which will connect them automatically. Or you can also go in the output interface and connect it to a global variable by clicking on this and then choosing the global variable that you like. Okay, so now that we did it, we connected the XY plane to this command box, and it will result the point on this XY plane. So I think it's a pretty good start to introduce the command boxes and how does it work. So every command boxes basically means an operator with an input and an output. You put one item into the input, which will turn green, which means that it's ready to compute. And at the other end of the operator will come out an output item. So basically, with our example of the point on plane, we put an item called of a plane in the input, and the output will be a point on this very plane. And you have a lot of different variables that you can change in this command box. Let's get back to our model. So for this point, we'll make it out of one plane, the plane XY of the reference. We could have make it start from a reference point, but we won't use it for now. Let's search for the next command, which is rectangle 2 points. It's in fact a rectangle that uses 2 points and a support as an input, and I'll let you know. So obviously you know why. So let's connect the first point with our reference of the reference model. The support of this rectangle will be the XY reference, but you could have make it with any other plane. We will connect then the point we just made with our rectangle, and now we change the dimension, the distances of X and Y in the point with the dimension we saw in the pictures of the Lego that we saw earlier. Okay, so it's 15.8 millimeter and 31.9 millimeters, and we can see the rectangle directly created on the left-hand side of the screen. So now we have our first rectangle, and in fact we are going to do a second one to have an inner volume that we will withdraw from the first one. So if we first have to duplicate the point, because we will make kind of the same one on the same plane, we just have to withdraw 1.2 millimeters out of those dimensions, because it's the thickness of the rectangle. Oh, just some bad news from my manager. No, don't worry folks, it's just an April Fool's. Okay, so now we will connect to a second rectangle. We make a second rectangle. The first point is still the same, the reference O. So we just double click on it and it connects. For the I just mistake and I put the reference O as the support, but just withdraw it and connect it to the XY plane. So for the second point, we will use point 3, the point called point 3. And now we have the second inner rectangle. Yes. As you can see, I connected it to the reference point, which is in fact a mistake. Sorry, my bad. So no, we create a second point from this rectangle, and we put the thickness of the rectangle we want to create to have the 2 points of the inner rectangle. I just put 1.2 meters, which is a little bit too much for a piece of Lego. So I just erase it and connect it and put it back. Okay, I make the right connections. And here we have our inner rectangle. And so now we have our two rectangles that appears blue on the left hand side of the screen. And we will now fill them to have two surfaces. From those surfaces we will make a volume, so you just connect it, drag and drop as usual, the output of the rectangle to the input of the fill, and here you have the two surfaces. Yeah! Now out of those surfaces we will create a volume, and to create a volume we'll go search for the volume part and the 6surface command box. We connect the surface with the command box. We do the same thing with the other rectangle. We put the right dimension, it's the thickness, the thickness of the whole Lego piece. And we just put 1 millimeters, 1.2 millimeters, we will just withdraw 1.2 millimeters as a thickness for the second volume. So now we just have two volumes in the same rectangle. We'll use the remove operation to remove from the volume 1 the volume 2. And now we just have to hide the other geometries in order to just keep the remove one. And as you can see, now we have an empty rectangle, an empty volume of rectangle. Nice. It's basically the shell of a volume like this. Now let's group it in order to don't make a mess out of our display graph, to keep it simple, because you will see if you use it and make really complicated models, it can be a real mess with the different input, output and data flows, and just keep it tidy up, please. Let's call it rectangle. I know it's not an original name, but let's face it, it's just a rectangle. And now we will extract one element of the previous rectangle that we just created in order to make the next geometry. So let's connect the rectangle, the first one, the big one, with the subelements command. You can see that we have different dimensions of subelements. You have faces, volumes, and edges. It may be a good time to make a quick review of this command box. So, out of the command box, you will have a list of outputs. And in this list of outputs, you will have item 1, 2, 3. And so basically, let's get an example with a cube. There is the dimension 3, which is the cube. Dimension 2 is the different faces, faces 1, 2, 3, 4, 5, 6. And the dimension 1 is the edges of those different faces. Okay, so from these subelements, we will withdraw one of the edges of the rectangle that we just connected to it. So there is only 4 items that you can see when you click on the green output button. 1, 2, 3, and 4 represent the 4 different edges of this rectangle. But we just want to get one out of those 4 edges in order to compute the next step of the geometry. So we will call the command box is called GetItem. We connect it to the previous command box, and with the index, which is one of the variables of this operator, we can take whichever item out of the previous list. So item 1, 2, 3, or 4, we take the first one, because we need only one. Out of this edges, because we just got one edges, we connect it to a point on curve that will allow us to select, to create a point on this curve, which is at a certain distance from the edges. So we do the same thing for the other side of this curve, with the right distance, of course. But let me think. Okay, now I think I don't have the good distance. Okay. let's do it again. Let me just delete it. Okay, so let's take the point on curve. We connect it to the curve which we want to put a point on. With the right distance, it's way better. We duplicate it with data flow, so it's already connected, and we just change the orientation of the point on the curve. Okay, so now we have 2 points on this face. We'll build a list because thanks to this we won't have to do twice the same operation. So out of this list, in fact, there is the 2 items, the 2 points that we just connected to it. And so now, thanks to this list, they will pass through the same commands, and there will be 2 outputs at the same time for the same command. So we connect it to line direction. We just need to enter a direction, and it's create a line automatically. We enter the right distance, so it's 31.9, which is the total distance of the Lego piece. So now we have a line that goes through all the piece of Lego, and we will begin to split this line. As you can see, to split we first need a point. We take the same point on curve, we duplicate it, and I think we don't even have to change the distance connected to it. Yes, that's the good distance. There is still 2 items out on the outputs because of the previous reason. So we put 2 points on this, and now we will use the split in order to keep only one part of this curve. So a first split that will split one edge of this line, and another one. So for the split, we put in the object that we want to split, and the other object that we want to split with. We do the same thing this time with the split as the object we want to split, and the point 10 has the point which we want to split it with. We change the orientation, and here we just keep one part of the line that interests us to put the center of the cycle that you will see later. So now we connect the splits to the divide curve that will divide the curve we just entered, put in by a certain amount of length. We point the with bounds option because it will take the bounds as the limits, and you can see our different items as the outputs. You can even click on the watch item in order to have it as a command box that will stay there forever, permanently. But it doesn't really interest us, so we just erase it, delete it. Now, from all those points, those different points, we will create the cycle with the point as the center. So we drag and drop it, we put on the good plane of supports, and we put the right radius of the cycle, which is this, I think. Okay, but let me think. I think there is a mistake. This is supposed to have 4 different items, and here we have 5. So, which is nice. What is nice is that we can go back to the point where we had the mistake, and as you can see, it's not on the divide curve. Yes, I think it's on the divide curve because no, this is the right distance between the different points. The split is no, this is right, I think. It's strange, it's all the right distances, but there is something wrong, so I think there is 1 millimeter that we have to withdraw. And so has it changed anything? Okay, so yeah, now we have only 8 items, so it's right, it was right answer. I don't really know why, but we just had 2.1 millimeter surplus in it, that's all. We fill in the different cycles, so we have surfaces, and we will seek the surface that we just created with the seek surface command, as usual. Now let's put the right distance of thickness, so it's from 0 to 9.6. Yeah, just checked it. But yes, of course, because 9.6 plus 2 millimeters is 11.6. And we will make it start from nearly the top of the rectangle that we already have. So we don't have any excess of cylinder inside of the rectangle, of the shell of the rectangle. Now we can all hide the not wanted parts and group this. Okay, so now we just put it in a layering style for the previous group, and we'll do the same for this one. Yeah, layering style. We will change the color of the group, of this group. First we'll change the name. We'll rename it by upper cylinder. Yes, I lack of originality today, but I guess that's upper cylinder for me. So let's put it in green. Yeah, green is a good color, of course. Not maybe the prettiest, but I don't make the color choosing. So now we'll do the inner cylinder of the Lego, of the piece of Lego. And it's pretty close to the previous upper cylinder style, so we will duplicate all the group and put it right at the bottom of it. We'll make in. So what are we going to change in this group in order to have our inner cylinder? So we will first withdraw the two different points. Okay, so out of the faces, we will make a point on curve by ratio, so we will be able to take the middle point, to have a middle point on these edges that will connect to the rest of the process. And normally, yes, so it creates us for now 4 different cylinder, 4 different cycle in the cylinder. We just have to change this number and to change a few other variables. The point on curve, I think, yes, we have to change this because it's not the same limits, of course. So 7.9 on the 2 limits. The splits are of the same condition. We maybe change the split. No, the divide curve. No, it's the same length, so it shouldn't be a problem. But I think there is 4 items out on the output, so maybe 8.12. Yes, we don't know. So we verify we have 3 center, 3 circle, but we don't want circle for this. We want 2 different circle that will make another kind of geometry. So we duplicate the first cycle with data flow, so we don't have to put the input into it. Which we have to change the different radius, of course, because it's not all the same as the previous group. So let me think, let me calculate. So for okay, I think it's 2.4 only, and here we're gonna add a little bit. Let me think again. 3.25. Yes. Okay. So we will use a different kind of filling, which is a blend that, in fact, create a surface between 2 curves. So we just enter the 2 different curves, and it will create a surface that will take as the output. And here we have the surface that will connect to the thickness that will make it start from the bottom, and that will go until the top of the Lego piece, 9.6 millimeters. And now let's see the results of this geometry. Yes, this is the inside of a Lego piece. I can tell because I really used a lot of them when I was a kid. This is it. Maybe we'll change the thickness because we still see the different surface on top. Okay, perfect. Now let's hide the unwanted part as we did earlier and put it in a layering style and group it. So you see, we did kind of the same thing. We repeated this kind of the same thing really easily by just duplicating it and changing some of the geometry. And to continue on our lack of originality, we'll call it inner cylinder. This yellow is really horrible. I think it will be perfect for our group. Now that we have our piece of Lego, there is maybe some details that are lacking, but we'll go through them. We'll change first the color. So in order to change the color, we first have to create only one geometry that we will put the color to. And so out of those 3 different thickness, we have to put only one. First, the thickness 4. We have to add the 3 of them together in order to only have one thickness out of it. So you can see the add one. We'll do the same for the second, for the thickness 3. So we connect it. And now we can see at the output that there is 2 add. Yes, because in fact there were 2 columns. And the output, column 1, column 2. So we have to do a little trick on the lists, which is to flatten the link. In fact, it will take all the items and put it in a simple list. As you can see in the output, there is only a simple list. And so the add command box, the add operator, will compute all those different items and put it in one add. And here we have only one add. The other remove is already only one piece. So now let's connect the 3 of them. So double click here, double click to the build list. For the add, we put it on the build list 2, and for the add 3. So you can see that we have our 3 different volumes in this list. And we duplicate the add because we want out of the 3 volume to only have 1 as we do now. And now let's hide the 3 previous commands. Hola. Wait, I think there is something wrong. Sometimes there is some little bug out of those commands, but it's normally not this. Let me hide a few things, but yes, I think I know it's a simple mistake. Sometimes doing this will help. No. Yeah, I know. In fact, it's in the building of the list. In the building of the list, there were a mistake. Yes, I put the right data flow, and here we have only one add. So this command box represents all the different volumes combined into one. So we have here our piece of Lego. Okay, so now let's put some color in this design. So we take the object for the volume add 3, and we have the color chooser connecting to the colorize. And we can then choose the color. So we'll first take the red. Okay, so you have to have only one volume, one geometry in fact, connected to the colorized for it to work. That's why we had to connect all those different volumes. So now that we have this beautiful red color connected to the volume, we have this piece of Lego that is red, that's pretty similar to the one I had when I was a kid, and that I found back in my stuff. Okay, so we group it. We will now create a mattress, because now is one of the interesting parts, apart from the geometry side, of course. We will enter in the mattress and parametric side of the application. So first we take a rectangular grid that we will create, and that will have the size and the volume of the piece of Lego, the dimension of the piece of Lego. So for the size of X, we entered 15.8 millimeters. For the size of Y, we put 31.9 millimeters. And the number of X and Y, you can choose it, it's no problem, but you have to take it by the edge of this and put it out of the command box. You will understand better later. So yes, we entered the right dimension. We can now just hide those two command boxes in order to focus on the rectangular grid. So everything is fine. So when you add some numbers to the numbers of X and Y, you can see the grid changing. We'll keep it at 3.3 for now. So now we are going to look for a little command in the transform tab, which is translates 2 points, that will take a geometry as an input, and that will transform it along a vector defined by the 2 points as the other inputs. So for the vector, we'll create another rectangular grid with the size of the eighths of the piece of Lego, so 9.6 millimeters. This will be the destination of the vector. So we just have to take the number X that will represent, in fact, the number Z in this situation. Just rename it X number. Renaming those command boxes can be pretty useful sometimes. When you have a pretty complex situation or model, you will be really glad to have renamed all those different command boxes that are sometimes really confusing, in fact. So that's why I didn't do it really a lot in this presentation, but I certainly do a lot now. So this rectangular grid will be our in. The reference O will be the first point of the vector, and the rectangular grid will be the second point. You can see the output is, no, this is not the right output. Why is that? Yes, I think I know, because exactly the same thing as previously, we have to change the list of the output as of this first rectangular list. So we will call the same thing called Flatten. We put it in the structure, and we can see as an in. Now, okay, so now we have a perfectly 3D rectangular grid thanks to this translate in the two rectangular grid, and it will be the size will depend on the X, Y, and Z number that we'll put inside. So if you want, we can watch it. So the first column is depend on the first X, second X, and third X. Okay, so this is it, but we don't really need it, so let's just erase it. Okay, so we have a perfect 3D rectangular grid. And now we will duplicate the translates, because this is the real thing that we want to translate is the add, that the volume of the Lego, in fact. And so the first point of the vector is, as usual, the reference O, and the second point of the vector is the translate the rectangular grid. Now we change the input of the colorized objects by the translates, which represent all the different pieces, and we just see the colorize. let's just hide the other things. We'll put all those different command box inside of the group, the previous group. So for the things that are just inside the group, just move it like this, and they will be considered as part of the group now. So we just hide this. We put all the group in a layering style. Change it. We'll change the color also. Which one didn't we use? Oh, beautiful orange. Beautiful. Magnificent. We take those 3 commands and we set them as a controller that now we can see inside of the virtual model. In the experiment tab, you have the control over the 3 different options that are directly connected in the display graph. And so if you change this number, X number, Y number, Z number, they will be directly changed inside of the display graph. I didn't really use it in this video, unfortunately, but this is one of the main aspects of this application, this xGenerative application. And I hope that you will get enough interest in this to look for other videos, other tutorials. There is plenty of them, and it's a really interesting application. For the color, we'll put the Dassault system still colored. So this is the code, the special code for this color. You can note it if you want. It's 005686. Why doesn't it want to move? Okay. So now all those cubes are in the beautiful corporate color of the Dassault system. Isn't it beautiful? And if you want, you can change anything on this rectangular grid. Just let me check. Okay, everything is in place. Yes. Okay. Okay, now everything is fine, everything is good. We just finished our model. And this is it, this is the end of the presentation for me. We just now can play with it as you want. So if we put 111, the rectangular grid will be on 111. And so we just will have one piece of Lego. But if we want, we could make a wall out of those bricks of Lego by just putting the first brick and then putting some on top of them. And here we have a wall of Lego of Dassault system corporate Lego. We just change the shadow and the mirror, withdraw the rectangular grid, and here we have a perfectly fine working wall of Lego Dassault system. Okay, I hope you enjoyed the video because this is the end of it. And if you have any question for me, you can now ask them. I will be available for 15 minutes. If you want, I can send to you some links about other videos about xGenerative design that really helped me learn about this application. I'll be really happy to advise you for this. And I hope you have a lot of questions, and I hope I will be able to answer them. Thanks for listening to me, and this is it for my presentation.
Thanks everyone for listening to me. I hope that you enjoyed this presentation. And now, if you have some question, it's now or never to ask it. I noted some questions that I received during the presentation. So first, are you really fired? No, I'm not really fired. It was just an April Fool's joke. No, some more serious question. Is there different methods to do some kind of thing? Okay. So to answer this question, is there any other method to do a model like that? Yes, there is plenty of different methods, different geometry that you can use, different function that you can use in order to do a piece of Lego like that, or any other geometric model. So it's really up to you. It's a really free application to design any model. And so just feel free to discover it and explore it as you want. Just over any function and see if those functions what you are looking for in this application. And So my only answer is discover by yourself. Okay, so another question. Is there any math and formulas in this application? Yes, actually I will show you now this xGenerative design application. So this is my current project, and in the design sequence graph, you can see, show you, yes, just loading. There is a math tab, as you can see, with a lot of different functions, different vectors, operator. So maybe in another webinar session, I'll be able to show you and demonstrate the use of this math application, but it was not the program of today's presentation. So not today, but maybe in the future. Okay, I got another question, like to show us more about your project. Okay, so this is my current project, as you can see. So it's the stackable bridge that I got today, but it's not finished. It's only the second draft improved with the body on the skeleton. So you can see that I put some geometry over the skeleton, and the main aspect that I was talking to you about is the capacity to change some parameters. So for example, if I want to change the number of pillars, of stackable pillars, I just have to click on this and the geometry will directly change. Okay, so it's kind of slow today because of my poor connection, but it's nearly instant when I'm using it. So if I want to put some more pillars on the left and on the right hand side, I just have to click here, and they will appear quickly. Fortunately, I can change anything that I want, the center of this stackable bridge. And you'll see that the center of it will change right away. And you can see you can change anything that you want, and in fact, it only depends on the stackable bridge. So as I showed you earlier, you just have to go in any command boxes, click on it, and when it's for click on it, and you will be able to change it. Like for example, this thing, just click on controller, and it will appear in this parameters, this tab, experiment tab. Okay. So to show you the size of it, it's actually pretty big for a display graph, but it could be really bigger if I want to put a lot of more details. I even was able to put some monitor in this. It's a graph or charts that allow you to get some information, basic information about your model. So here I put my pillars 8, and so you can see that all the pillars have different items referring in this little chart. And it will directly change with the different parameters that will change. Here it's directly changing. There is also different things like alignment length. The full length of the alignment is displayed here. The length of the bridge, only the bridge parts between 2 points, and the bridge width. So you can see that you can play with a lot of different parameters easily and have the display graph instantly produced. So this is one of the main aspects of this application. Maybe put a little bit less. I can even play with the ratio of the cable. Like if I want to put it this way, it will change for the better or the worst. And hopefully at the end of my project, we'll be able to change the geometry and simulate all the forces that are applied on our model. It will allow us to choose the best model and the best parameters for the model. So this is the main application. This is the main thing of this application, the xGenerative design application. Now I'm just looking if there is some other question. List of tutorials. Yeah, I will send you a list of tutorials after my after this little Q&A session, and I will send them in the chat, or I will even put them in the comments of the videos on our swim page, on our academic.3ds.com page. It's some videos made by some experts that really help me get this the application usage. And thanks to those videos made by a lot of different people in data system, I was able to quickly get the purpose of this application and how to use it. It's really easy to use. Just try it and you will thank me later. But this XDesign path is easily available in the rich client. XDesign path. I made it out of scratch. Like I all did it with I did the surface and the alignments in CATIA with the civil engineering role application, and then I imported it in my xGenerative design application. To do so, you just have to, I'll show you here, just save it. You can look here for the search for any application that you want. So first, I will show you here, bridge. I have my bridge. Search for any model, 3DEXPERIENCE model. After looking for it, I can just pin it to my taskbar. And then I just have to look for it. Which one? This one. And just to drag and drop it. And so from a 3D XML model made on CATIA, you can directly import it on our application, on our web application. After loading, you will be able to play with all the different parameters, surface that you want. So this was the first draft that I made, actually. There are some other questions that I already told you I'm not an expert in xGenerative design, and I see some questions that need some more expertise eyes. So I will note this question and then answer it in the comments of this video after looking for the right answer. I don't want to say some wrong answer to you, so I will just note them and after that answer it with some expertise opinions. Okay, so I think I answered kind of all the questions. For the other links for the other videos, I will send them in the comment of this webinar and in the comment of our post on the swim page or anything that we'll post our videos on. Other than that, drawing functionality available. You can draw as you are drawing a shot in CATIA, but you can do as I did on the first part of this video, like to display a point on a plane, and then from this point continue on the geometry, putting lines and all other points. But you can't make a drawing as we are used to in the CATIA application, unfortunately. And I think that's all for this presentation. So thanks everyone to attending it and to following it. Just feel free to contact me if you want, if you have any question. And we'll see about that later.